Hello all, welcome to a new video on logic design. In this video, I have explained the mapping and minimization of POS expression using a two-variable Kmap. In my previous lectures on Kmap, that is in part 1 and part 2, I have explained the mapping and minimization of SOP expression using the two-variable Kmap. In my subsequent lectures, I'll be explaining the simplification of Boolean expression using the 3-variable, 4-variable and 5-variable Kmap. If you are new to my channel, check out my videos on the selected topics from the course of Logic Design and a few videos on the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So without further delay, let's get started. First of all, let us see the mapping of POS expressions. POS means product of sum. So each sum term in the standard POS is called a max term. A two-variable function, let that variable be A and B, has 4 possible max terms, that is 2 to the power of 2, that is 4 possible max terms. Which are those 4 possible max terms? They are A plus B, which is denoted as M0. M0 denotes the max term of A plus B, and A plus B bar denotes M1. A bar plus B denotes the max term M2, and A bar plus B bar denotes the max term M3. Here M stands for max term and its subscripts, which are the subscripts 0, 1, 2, 3 are the subscripts. So its subscripts denote the decimal designation of that max term. In POS, the non-complemented variable is treated as 0, which is the non-complemented term here, A. A is treated as 0 in POS and the complemented variable is treated as 1. Here A bar, this is the complemented variable. So this A bar is treated as 1. Similarly, B is treated as 0, B bar is treated as 1, C is treated as 0, C bar is treated as 1, etc. For mapping a POS expression, we have to draw a two-variable Kmap. The two-variable Kmap consists of 4 cells or 4 squares, 1, 2, 3, 4. These are the 4 cells or 4 squares. The variables are A and B. So this two-variable Kmap consists of 2 columns and 2 rows. Here 4 cells are there. The first cell denotes the max term M0. Second cell denotes the max term M1. This cell denotes the max term M2 and this cell denotes the max term M3. So when you write the POS or the product of sum term of the first square, it is A plus B, that is A plus B denotes the max term M0, A plus B bar denotes the max term M1, A bar plus B denotes the max term M2 and A bar plus B bar denotes the max term M3. So these are the 4 cells which denotes, each square denotes one max term. Each square or each cell denotes one max term. Let us understand how to map the given POS expression through this example. So the given example is plot the expression f is equal to a plus b into a bar plus b into a bar plus b bar on the Kmap. So we have copied the given expression as it is. This is in POS form, that is product of sum form. You can see 3 terms here. A plus b is the first term. Second term is a bar plus b. Third term is a bar plus b bar. Now the first step is we have to write this POS expression in max term expression. We have to convert this into max term expression. For that, the literal without the bar is denoted as 0 and the literal with bar is denoted as 1. For example, here this literal A is not complemented. It is non-complemented. Therefore, it denotes 0. Similarly, B is also non-complemented, or this is a literal without a bar. So this literal or the variable denotes 0. Here this literal has a bar, that is, it is in complemented form. A bar denotes 1, B denotes 0, B bar denotes 1. Similarly, A bar denotes 1. So a literal with a complement denotes 1 and a literal without the complement denotes 0 in POS. In SOP, it is just the opposite. Here we are considering POS. Therefore, the literal without a bar is denoted as 0 and the literal with a bar is denoted as 1. Now we have to write the max term expression from this. What is the decimal number for 00? 00 is in binary form. So write the decimal value of this binary, that is the first term, it is 0. Similarly, for the second term, the binary value is 10, the equivalent decimal is 2. And for the third term, the binary value is 11 and the equivalent decimal is 3. Now, with this decimal values, we have to write the max term expression, that is f is equal to pi m of 0 to 3. 0 to 3. Now, in the next step, we have to minimize this. We have to minimize or simplify the given POS expression. For that, we have to draw the Kmap. How many variables are there in this expression? 2 variables. Which are they? A and B. Therefore, we have to draw a 2 variable Kmap. So this is a 2 variable Kmap which consists of 4 cells. The variables are A and B. It is having 2 rows and 2 columns, and the first cell denotes the term A plus B or the max term M0. The second term denotes, not term, second cell or square. This denotes the max term 1 or the term A plus B bar. Similarly, the third and fourth, 2 and 3, M2 and M3 respectively. Now we have to place zeros. We have to place 0 in the cells or the terms, the max term which are present here in the expression. Which are the max term present in the expression? 0, 2 and 3. Therefore, we have to place 0 in the corresponding cells. That is, in the cell 0, that is M0, M2 and M3. And whichever terms are absent or whichever max term is absent in this given expression, there you have to write, or you have to place 1, or you can leave it empty. So the mapping of this given expression is done. Now let us see how to do the minimization of POS expression. So the first step is map the given POS expression onto the Kmap. That is, placing zeros to the squares or the cells. Then combine the adjacent zeros into large squares as possible. Then read the squares putting the complemented variable if its value remain constant as 1 and the non-complemented variable if its value remain constant as 0. Like for example, if the value is A bar, you have to put 1 for that, and if the value is A, you have to put 0 for that. And then write them as a sum term. So these are the steps that we have to follow to minimize the POS expression. Now let us consider an example here. Here you have a two variable Kmap, and I am going to place zeros in the cells M0 and M1. So I have placed zeros in M0 and M1. So we know that when the adjacent cells contains zeros, we can group them in POS. If it is an SOP, the adjacent cells should contain ones instead of zeros. So here in POS, the adjacent cells contains zeros so that we can group the zeros. So mapping is done by placing two zeros. Since these zeros are adjacent to each other, we can group this zero. Now what is the next step? Next step is read the Kmap. So when you read the map, you can see that this 0 which corresponds to A, it remains constant throughout this square. It remains constant throughout the square, and this B changes from 0 to 1. That is, B changes from 0 to 1. So we know that when the variable changes, we have to ignore that variable, and whichever variable is constant, we have to retain that. So in this case, this variable is constant, that is 0 which corresponds to A is constant. Therefore we will retain that, and this variable will be ignored. Therefore the minimized expression here is F1 is equal to A. Now let us consider another example here. Here I am going to place zeros in these two cells, that is in cell 1 and cell 3. That is M1 max term M1 and M3, the cell which corresponds to the max term 1 and max term M3. So here I have placed zeros. So here these cells are adjacent to each other and it contains 0. Therefore we can group these cells. So mapping is done, grouping is done. Next step is we have to read the Kmap. So here you can see that this variable B, not B, it is B bar. Since it is POS, 1 corresponds to B bar and 0 corresponds to B. So the variable B bar is constant throughout this square, and the variable A is varying from 0 to 1. Therefore we are going to skip this and we are going to retain this B bar. Therefore the minimized function is F2 is equal to B bar. Now in this case we are going to place zeros in the cell 0 and 2. Since these two cells are adjacent to each other and it contains 0, we can group these two cells. Now we have to read the Kmap. So here you can see that the variable B is constant throughout the square. The variable B is constant throughout the square, and the variable A changes from 0 to 1. Therefore we have to ignore this variable A and retain the variable B. Therefore the simplified function is F3 is equal to B. Now in this case we are going to place the zeros in cell 2 and 3. Since these two cells are adjacent to each other and it contains 0, we can group these two cells, and we can see that the variable A bar is constant throughout the square and the variable B changes from 0 to 1. Therefore, we have to ignore the variable b and retain the variable a bar. Therefore, the minimized expression is f4 is equal to a bar. Now, in this case, we are placing zeros in all the cells. Cell number 0, 1, 2, 3, all these cells are adjacent to each other. Therefore, we can group all these zeros. Now, when you read this, you can see that the variable b changes from 0 to 1, the variable a also changes from 0 to 1. Therefore, the minimized expression is f5 is equal to 0. Let us do this example. Reduce the expression f is equal to a plus b into a plus b bar into a bar plus b bar using mapping. So, the given expression is in POS form. We have to convert that to max term expression. For that, this a, b, these are in non-complemented form. So, the variables in non-complemented form has to be denoted as 0 and the variable in complemented form is denoted as 1. Therefore, here a plus b, a and b are denoted as 0 and here in the second term a is denoted as 0 and b bar is denoted as 1. Here a bar and b bar is denoted as 1. Now, what is the decimal value of the binary 0, 0? It is 0. The decimal number of this binary value 0, 1 is 1 and the decimal number of this binary value 1, 1 is 3. So, from this we can write the max term expression. It is f is equal to pi m 0, 1, 3. The next step is we have to plot the Kmap and place zeros in the cells 0, 1 and 3. It is given here 0, 1 and 3. So, we have placed zeros in the cells 0, 1 and 3. Here we can form two squares because cell number 0 and cell number 1 is adjacent to each other and it contains 0. Similarly, cell number 1 and cell number 3 is adjacent to each other and it contains 0. Therefore, we can group these two cells and these two cells. This is called as overlapping. That is, this single cell which contains 0 has been grouped with this cell as well as this cell. It is cell 0 as well as cell 3. So, this is called as overlapping. Here we have two groups. Now we have to read the Kmap. So, in order to read the Kmap, we have to consider two squares here. First, let us consider this red square. Let us read this part. So, here the variable b is changing from 0 to 1 and the variable a is constant. That is, here this a is constant throughout this red square. Therefore, we can read this part as a. Now, let us consider this square, this yellow square. Here we can see that the variable b is constant throughout the square. We call this as b bar. 1 is denoted as b bar here. So, this b bar is constant throughout the square and this variable a is changing from 0 to 1. Therefore, we can call this square as b bar. Therefore, when you combine these two squares, you will get the reduced Boolean expression as f is equal to ab bar. So, when you implement this, we have to implement this using a AND gate, and when you give the inputs this a and b bar, you will get this f which is equal to ab bar.